This section covers 5-5. You're doing page 5-5, page 224, 1 through 53 odd. We are simplifying polynomials. You're working out of the green book, and you should have this done by 1:16:19. We will check it when you come back on when the strike is over. All right, so to simplify polynomials, first we need to talk about some of the language. A monomial, as we mentioned before, is a single term. Single term consisting of numbers, variables, and whole number exponents. So 7x squared is a monomial. 3m, because that's m to the first power. 10a to the first b squared c. Negative 2 4/10 y. Now, I want you to notice it says whole number exponents. Okay? Whole number exponents. That means the coefficient can be negative, but I can't have a negative exponent like something like this. Okay? Coefficients can be negative, but you have to have whole number exponents. That means positive exponents. A polynomial, mono means single, poly means many, right? A polynomial is an expression consisting of two or more monomial terms that can't be combined. So, for instance, two or more that are unlike terms, that's what we mean. So if I had 5x squared and plus 2x, these are unlike terms. A term is alike if the variable and the exponent are the same. And since this variable is to the first power, these are unlike terms. So this would be a monomial consisting of two or more terms that can't be combined. So this is a polynomial because the terms are unlike. There are special kinds of polynomials. The first kind is called a binomial. That's made up of two terms. So a binomial has two terms. They look like these. And a trinomial looks like this. Has three terms. Tri as in tricycle. So, pause the recording, take notes if you need to. Now, let's continue. All right, so now I'd like you to pause the recording, and identify each expression as a monomial, binomial, trinomial, or polynomial. If it is a binomial, trinomial, it will also be in the polynomial category. So two of these may apply. So why don't you pause the recording and try this slide on your own. Now check your work. Number 1 is a binomial and a polynomial. Number 2 is a trinomial and a polynomial. Number 3 is just a monomial. It is not considered a polynomial. Number 4 is just a polynomial. There's no special name for when it has more than 3 terms. Number 5 is a binomial and a polynomial. And number 6 is a trinomial and a polynomial. All right. Now, state whether each expression is a polynomial. If so, state the number of terms and the coefficient for each. I'd like you to, we'll do the first one together, then I want you to pause the recording and state the answer, the 3 questions. First, you're asked if it's a polynomial. Then we want to know the number of terms and what is the coefficient. So the first one is a polynomial. And in fact, it's a trinomial, though they're not asking that. And there are 1, 2, 3 terms. And the coefficients are, the first one is 1. The second coefficient is -3. And we don't usually talk about, this is called a constant term. So we don't usually talk about 8 as a coefficient. Okay, one more time. It's a polynomial to number 2. And it has 3 terms. And the coefficients are 5, -1, and 8. Pause the recording and try number 3 through 6. Now check your work. Number 3 is not a polynomial. The coefficient would be 15, but we're only asked to state the terms if it's a polynomial. Number 4 is a polynomial. You have 7 as a coefficient, -1, -4, and 6, and there are 4 terms. Oh, sorry, 6 is not a coefficient. Number 5 is not a polynomial because t squared really means t to the -2 power, and we said that you have to have a whole number exponent. Okay, so this is not a polynomial. However, t to the 4th in this case is a whole number power. Remember, when it's in the denominator, it's a fractional, it's a negative exponent. When it's in the numerator, it is a whole number exponent. So this would be a polynomial, and there are 2 terms, and the coefficient is 1/3. Okay, moving on to the next one. So standard form for the polynomial is where we put the powers of the variable written in decreasing order. So we put the terms in order by looking at the exponents, and they go standard form, they go from the highest exponent to the lowest. So we call this descending order or decreasing order. Non-standard form would be any way that they're placed as a group. But standard form would be to take the highest exponent first. So the term with the highest exponent would be -x to the 4th. The next, it would be 7x to the 5th. Once I do it, I cross them out. Then I have -x to the 4th. The next one is positive 4x squared. Then we have -3x. And then we have our constant term, which has no variable, plus 8. And if you want to think about it, it's really because it's 8x to the 0 power. Remember, anything to the 0 power equals 1. So 8 times 1 equals 8. And that's why we don't usually see this x to the 0 power, because it disappears. But that would be the order. And x here is to the first power. If you see an x, it's to the first power. So this is what we call standard form. All right, take a minute, pause the recording, and try putting the next few in standard form. That means from exponent's greatest number to the least number. Now check your work. We'd go 5x to the 4th, or 5y to the 4th, plus y minus 2. Number 2 would be 2m to the 5th, minus m to the 3rd. Notice the sign travels with the variable. The sign that comes before the variable travels with it. Minus m to the 3rd, plus m, plus 6. Next one, -t to the 6th, positive 4t to the 3rd, positive 8t squared, positive t, and -2. Constant terms always going as the last term. The last one is negative 2k to the fourth, k to the third, positive 9k squared, negative 3. All right. Simplifying polynomials. We're basically combining our like terms. We'll be given a certain number of terms, and we have to put them together, combine the like terms, and put them into standard form. So we're going to combine our like terms. I generally like to work with the highest term first. So let's see. In terms of 3x to the fourth, may as well do two things at once. Put it in standard form and combine like terms at the same time. So 3x to the fourth and 7x to the fourth. When we're combining like terms, all we do really is add those coefficients. Putting how many x to the fourth together. So I have 3x to the fourth plus 7x to the fourth. That makes 10x to the fourth. Once I've used them, I generally try and cross them out. Now we've got negative 2x to the second and positive 3x to the second. That makes positive x squared. Cross them out. Then I have positive 5x and positive 9. Okay. So putting them in order of the exponents, combining them with their like terms. Remember, we only add the coefficients. So number 1, why don't you pause the recording and try these on your own. Now check your work. So we'll start with our t to the fifth. I kind of like to circle them. T to the fifth, negative t to the fifth, and negative 4t to the fifth is negative 5t to the fifth. Okay. Then we go on to t squared. I'm going to cross those out. I've got 6t squared and 5t squared make plus 11t. Cross them out. Next I've got positive t and minus 7t makes negative 6t. And then we've got our plus 6, our constant term. All right, next one, let's check our work. We're combining negative 4a to the third and negative a to the third makes negative 5a to the third. Then we've got 6a squared. It doesn't combine with anything. And now we're going to combine our a's. It's negative 9a plus 3a. That makes 6a's. Negative 6a's minus a makes negative 7a's. And finally, we are doing, oh, that's it. There's nothing left. All right, simplify the following polynomials. Write them in standard form so you can practice some more. Pause the recording. Now check your work. You should have 3m squared plus 4m minus 6. I would just put them in order right away. I wouldn't do the two steps the way my PowerPoint is doing. 7t squared plus 2t plus 11. And the last one is 8y to the third plus 9y plus 9. All right, so here's a typical kind of problem-solving problem they might use. Find the perimeter. So they're just having you utilize this skill, finding the perimeter. To find the perimeter of any figure, we have to add up all the sides. So in the first one, we're going to add up 2x plus x plus 4 plus 3x minus 1. And then we combine our like terms. 2x plus x makes 3x plus another 3x makes 6x. And then we add 4 minus 1 is 3. So the perimeter of this figure is 6x plus 3. Let's look at the next one. This one's a little trickier because you're missing the dimension for this side right here. But they give you the entire side and they tell you that this portion is 3a. So the remaining side, this must be 2a in order for it to equal 5a. So now we know our dimensions and we add them all up. 5a plus 3a plus 2a plus, we have to do the same thing for that horizontal part. If the whole thing is 7a and the small part is, if the whole thing is 7a and the small part is 3a, then this part must be 4a. So we're doing 7a, 5a plus 3a plus 2a plus 4a plus 3a plus 7a equals 24a. Pause the recording, try the next two on your own. All right, well, if this side equals 2x and this is a parallelogram, which it's looking like, then that means this side must be equivalent to this side. And this side must be equivalent to this side. So really we're doing 2 times 4x plus 1 and 2 times 2 times 3x plus 4. And then we distribute and combine like terms. Okay, so here we've got 4 times x, and we've got 2 times 2x plus 2 times 2 times the quantity of x plus 1. So we've got 4x plus 4 times x plus 1. We distribute our 4x plus 1, and then we combine like terms, and we get 8x plus 4. All right, last part for this section is the degree of a polynomial. So the degree of a term is the sum of the exponents of the variables. So in this case, the degree of this term would be 5. If I add, all we have to do is add up the exponents. The degree of this term is 11 and 3 is 14. The degree of this term is 2 plus 1, don't forget about that 1, plus 4, that makes 7. And the degree of the last term is 0. So it would be a 0 degree term. Then we can find out the degree of a polynomial. And the degree of the polynomial is really designated by the highest term in the polynomial. So for instance, this term is a third degree term. This is a second degree term. And this is a 0 degree term. So the term of the polynomial would be a third degree polynomial because we go with the highest term. Okay? Pause the recording and do the next 3 on your own. All right, let's check our work. So on the next one, since we've got 6 for the first term, we've got 6 for the first term, we have 9 for the first, and we have 12 for the third term. So it's a 12 degree polynomial. The next one we're going with, this one equals 10, this is 5, this is 8, so it's a 10 degree. The next one, this is 5, this is 9, and this is 2, so it's a 9. The degree is, it's a 9th degree polynomial. And that really is it for the lesson.